So we're doing something that you've already looked at last year in 20-1. All of Math 31 just finished it, so this is completely review for them. And it's not that hard a concept. It is one more thing you're going to have to look out for, that even writing the quiz today, there's things we took for granted, and that's that they're going to have a vertical asymptote if there's an unknown in the bottom. And that's not always true. You can either have a vertical asymptote or you can have a point of discontinuity. Now, a point of discontinuity just looks like this. Okay? To be discontinuous means, hey, that's not continuous. Okay? So there's a break in the chain. There is a hole in the graph. That's simple. So we have to find out today, is it a hole in the graph or is it an asymptote? And that comes from factoring both the top and the bottom. So we're going to go right to page 467. And we're just going to do 2 examples, and then we're going to let you go for it and finish your work in class. And I will get the unit exam back today, so the unit 6. So then we're kind of all caught up. I'll get everything on School Zone. I got the last stuff on School Zone. I need you to get all the homework in that you have to do. I'll get this so you will know your exact mark with 2 units, well, with 3 units left. And it's always good to know where you stand and make sure there's no mistakes in what I put in and all that stuff, right? So don't leave that to the end to even find mistakes. So here are the 3 steps. The first thing you're always going to do is factor the rational expression. Now, by factor, I mean the top and the bottom. And then simplify by canceling any common factors. Like, is there anything that can cancel? And then substitute the non-permissible value into the simplified form. Now, police officers just talking about your calculator is and isn't going to help you very much on this. I will show you how it can help you, and I will show you how it can't help you. Okay? Now, the best way to figure out what a point of discontinuity is let's do an example. Now, the question that you see here is difficult for 2 reasons. Number 1, I know some people are going to dive right in and go vertical asymptote at 1. Woohoo, that was easy. And no horizontal asymptote, right? Because isn't that easy? Look how fast that was, right? And you got it wrong. So the thing you always have to do now that you didn't do 10 minutes ago is you have to factor the top and the bottom. Because if there's anything that cancels that denominator out, it is called a point of discontinuity, not a vertical asymptote. Okay? Now, the other thing that's tricky about this one is people are going to look at that too quick and think that's x squared minus 7x plus 6. Okay? So they're going to, what, 2 things added to negative 6? You know what? Oh, that's easy, done. And that's there waiting for you on the diploma too, or my multiple choice. So be careful to look for things like this and go, oh, that's not going to be so easy. Now, there is only 2 options that can occur. A vertical asymptote at 1 or a point of discontinuity at 1. So always kind of think, well, if it's a point of discontinuity, that means x minus 1 must be on the top and the bottom, right? So I'm going to actually use this as kind of a hint on how I'm going to factor this. Now, because this is an x cubed, I actually have to use my friend synthetic division. Okay? So let's see if we can go all the way back to that unit. Remember, perms and columns was in between that unit and this. First of all, what number would I put on the outside if I wanted to divide it by x minus 1? Good. What numbers would I put across the top? 1, 0, minus 7, 6. Does it seem like a long time ago that we did this? It was only like 3 weeks ago. Okay, now, Drop the 1. 1 times 1 is 1. Add them, you get 1 away. 1 times 1 is 1. Add them, you get negative 6. 1 times negative 6, negative 6. Sweet, that's what I wanted. So now, remember, I'm just factoring the top. I picked 1 as a, x minus 1. So now we have x minus 1, and this would be written as 1x squared or plus 1x minus 6. Now, since it's x squared, I can factor it. So what could I find that I need to add to 1 and multiply to negative 6? What are they? 3 and negative 2. So this factors to be x minus 1, x plus 3, x minus 2. So I factored the top, right? So now my actual, this is x minus 1 times x plus 3 times x minus 2 all over x minus 1. Oh, what a surprise. I was not expecting that. Now, if you have an x minus 1 on the top and an x minus 1 on the bottom, what do? They cancel. So f of x equals x plus 3 times x minus 2. Is this correct? No, f of x does not equal x plus 3 times x minus 2. It equals x plus 3 times x minus 2, where x cannot equal 1. So what I'm trying to say here, if you want to come to the very bottom of your page, this is a good, what I'm trying to kind of sum up in one thing is x plus a does not equal x plus a, oops, I should probably write an a if I want x plus a times x plus b over x plus b. These are not equivalent. Even though, after I cancel it, it looks the same. Like, what do you mean they're not the same? They're not the same because this equals x plus a, where x cannot equal negative b, right? Does that make sense? If that makes sense, then you have understood this whole thing. Okay? Now, what I want us to do is put this original equation into our calculators, okay? And I want everybody to do it. Okay, so not your worked out question, because maybe we did it wrong. Always try to put in the original, x cubed minus 7x plus 6 over x minus 1. And zoom 6. Now, at x equals 1, there's supposed to be a hole. There's supposed to be a hole right there. But your calculator does not show a hole. Now you can hit zoom decimal, but I find that because the window settings are so bad, that most graphs don't fall in it. Okay? But here's how you can tell. Now I want you to just hit trace, I don't know, let's do -2, and then hit enter. Does everybody get the spider right there? Now, I want you to hit, you don't have to hit it again because you're already in that mode, but just hit 1, enter. Do you see how it doesn't give you a y value? That's the way you know you got it right. So, if I was to draw this graph, accurate way to draw this graph is I would need to, at 1, there's actually a break there at x equals 1, right? This is truly how the graph looks. Now, did your calculator show you that? Sort of. Because I knew where, and you could probably go to table. Table will actually show you. So if I hit second graph, which is table, okay, so that's how I would check that out. Okay, so there's another way to be able to check these. Now, the question would be, what is the coordinates of the point of discontinuity? Now, the coordinates are quite easy to find. Your calculator will not give them to you, as you can obviously see. One error is not a coordinate. Okay? So all you have to do is put your non-permissible in your new found equation. So all you have to do is substitute x equals 1 into x plus 3 times x minus 2. So 1 plus 3 times 1 minus 2 is 4 times negative 1, which equals negative 4. So the actual point is 1, negative 4. Okay, so just quickly, what are the zeros? Come on, you guys, you need to remember this. You need to know it. What are the zeros? Negative 3 and 2. Very good. Because you could see that from your graph, or you can also see that from your equation, right? That's what makes it equal 0. Because zeros equal two other things. What are they? X-intercept and roots. Okay? Okay, let's do one more. The only difference between example 2 and example 3 is the factoring is harder, but the concept is the same. Okay. Now, whenever you do these, factor the bottom first, okay? So, denominator first, okay? Or bottom, whatever you want to put. See, because that's going to give me hints on what things I can put into my synthetic division at the top. So, I'm going to factor the bottom. I'm looking for, let's do this first. So I'm looking for two things that add to give me 7 and multiply to give me 10. 2 and 5, or 5 and 2, right? So 2x squared plus 5x plus 2x plus 5. So I'll factor out an x. It's x plus 5. I'll factor out a 1. It's x plus 5. So we are x plus 5 times x plus 1. Okay, so that is the bottom. Now, 2x plus 5. So that's the bottom. So now we need to do the top. Now again, let's use wisdom here. Even when I look at this question, I see this is a straight line with 2 points of discontinuity. That means how many things are going to cancel? 2 things are going to cancel. So what is one number that I should try outside here right now? Which one? Negative 1. I wouldn't go for negative 5 over 2 because that's just ugly, right? So you do the negative 1, and then you're going to have easier math to do. Even if you did want to do that, that's good. You could do it, but you're going to be hating life. So there's 1, negative 16, and negative 15. So drop my 2. Negative 1 times 2 is negative 2. Add them together. Negative 1. Negative 1 times negative 1 is 1. Negative 16 plus 1 is negative 15. Negative 15 times negative 1 is 15. Yay, they cancel. So right now, x plus 1 times, this is 2x squared minus 1x minus 15. Now remember, when they're at the x squared stage, I can just use my what do things add to give me negative 1 and multiply to give me negative 30. What are they? Negative 6 and 5, right? So this is x plus 1. That's still staying out there. This is 2x squared minus 6x plus 5x minus 15. X plus 1 is still out there. This is, I can take out a 2x, leave me with x minus 3. I can take out a 5, leave me with x minus 3. Finally, I am done with x plus 1 times x minus 3 times 2x plus 5. Okay, so x plus 1 times x minus 3 times 2x plus 5. Remember, that was the numerator, and the denominator, 2x plus 5 times x plus 1. So what you do is you do some canceling. There and there, there and there. So my final answer is, so this was f of x equals x minus 3, and x cannot equal what cannot x equal? Negative 5 over 2 and minus 1. Now, we want to make a rough sketch to be able to actually... Now remember, this is... Does anyone know what the equation of a straight line is? Y equals... What's that number in front of... What's that thing in front of the x always? So slope is mx plus b. So this one, what is the slope? It's a number in front of the x. What's the slope? 1. What is the y-intercept? That's b. That's what b stands for, y-intercept. What is it? Negative 3. So the y-intercept is at negative 3. And we're going up 1 over 1, up 1 over 1. So up 1 over 1, up 1 over 1, right? So it's going to come over here at 3. So this is the graph. Now that's the graph of x minus 3. We're not doing the graph of x minus 3. We're doing the graph of x minus 3, where x cannot equal negative 5 over 2 and x cannot equal negative 1. So negative 1, right? Here's negative 1. And negative 5 over 2, that's negative 2.5, right? So that'd be like over there. So you're going to see, if you just come down, you should have a hole here and a hole here. Now what I'd like to do is find the coordinates of those holes. Now, how do you find coordinates? You got f of x equals x minus 3. And all you do is you take your non-permissibles and put them in there. So you've got negative 5 over 2 minus 3, which is the same thing as negative 5 over 2 minus 6 over 2, which equals negative 11 over 2. So the one coordinate is negative 5 over 2, comma, negative 11 over 2. That's the xy. So that is the coordinate of that. The other one equals, I'm going to put a negative 1 in there. So negative 1 minus 3 equals negative 4. So the other coordinate is negative 1, negative 4. Then you have to see, if you look at this, that's a pretty nice written response to give on a, I mean, look what stuff I'm testing. I'm testing your factoring. I'm testing do you even know the difference between asymptote and point of discontinuity, right? Okay, so we're doing 1 to 3 and 5 to 11.